for transformation number 2, we can see we have standard form instead of vertex form. So again, h and k, when you can identify the vertex by looking at the equation, that's called vertex form. Otherwise, we have the form y equals a times x squared plus b times x plus c, and that's standard form, standard form, standard form. And over here, that's vertex form, vertex form. Well, anyway, we can't directly find the vertex by looking at this form, so we have to work for it a little bit. And so we were taught that the x-intercept, the x-coordinate of the vertex is this special little expression, x equals negative b over 2a. That is a very, very important expression, because when we know what the x-coordinate of the vertex is, we know a lot about the graph, and then we can proceed from there. So let's find that. Let's identify, though, the a is always the number that we call the coefficient of the x squared term, coefficient of the quadratic term. Since we don't see a number there, we understand that number to be a 1. So we have a is equal to 1. The b is the number that is the coefficient of the x term, that's a 6. And then the c, we don't really need the c for this, but just for example's sake here, c is equal to 8. And so negative b over 2a is equal to negative b being 6 over 2a, which is 1. And we get negative 6 divided by 2, negative 6 divided by 2, which is negative 3. So there's our x-coordinate of our vertex. And so let's figure out what all we know based on that. 1, 2, 3 over here. When x is equal to negative 3, we know that equation is actually also the equation for the axis of symmetry. And if we write that down, we can just label our axis of symmetry right off the bat. Now all we have to do is find, well, what's the y-coordinate if we know the x-coordinate? Well, to find the y-coordinate, we just replace x with the x-coordinate of negative 3. So if we want to find the y-coordinate of the vertex would be negative 3, replace x with negative 3 squared, plus 6 times negative 3, gosh, I'm squeezing this in here, plus 8. So hopefully we can read this. 9 minus 18 plus 8. 9 minus 18 is negative 9. Negative 9 plus 8 is negative 1. So we have our x-coordinate of our vertex is negative 3. Our y-coordinate of our vertex is negative 1. And we have a dot right there. And we label it vertex, negative 3, negative 1. We can see that because the a is positive, we know the graph opens up. So let's go ahead and open it up. Now, if the a is positive 1, then we know we can always go over 1 and up 1, so we can get the x-intercepts for free, but we'll still work for those. I mean, we'll show you how to get those. And then we draw the graph, and then we'll draw the graph up here somewhere. Normal width, and there's our graph of our parabola. Make sure it's nice and curved down here in the bottom. Don't draw it like an absolute value graph where it's a sharp point. This is not a sharp point. It's a nice smooth curve right there. So there we have our graph. And we can go ahead and start identifying our domain, range, and all the other things. So the domain of every quadratic function is always all real numbers. The range, again, you identify the lowest y value, and the lowest y value would be the y-coordinate of the range. And so if it opens up, that is. So the range then in interval notation would be from negative 1 to infinity, including negative 1 and going all the way to infinity. Or you could write it like this: y is greater than or equal to negative 1. And that's the minimum value as well, negative 1. So the increasing and decreasing, we know this function is decreasing until you get to the axis of symmetry, and then increasing to the right of the axis of symmetry. The y values get smaller on the interval from negative infinity all the way to negative 3, and the y values get bigger from negative 3 to infinity. Remember that the red and the green, it's just like the last graph. You see the red and the green represent decreasing here and then increasing. So as you read a graph, you're always reading it from left to right. Horizontal asymptotes and vertical asymptotes, just like the last one, there are none. There are no horizontal or vertical asymptotes when we're dealing with polynomial functions. I'll save the intercepts for the next video. There's no maximum value, but we do have a minimum value of -1. Not 1-to-1. None, no. Slope NA, or we can say, again, it's increasing. Increasing. And the vertex we already identified to be -3, -1. And the axis of symmetry also, again, is always it's always an equation. X equals -3.